13,047 characters. Within the target range, here is the script. The island of Mindanao cracked open 4 days ago, and it has not stopped moving since. A magnitude 7.8 earthquake struck at 6:43 in the morning when the fishing villages along the eastern coast were already awake, the markets were open, and the children were on the roads to school. The shaking lasted 47 seconds. In the first 11 seconds, more than 340 buildings in 6 municipalities ceased to be buildings. The ground displacement measured at the epicenter was 1.4 meters of lateral shift in a single rupture event, the width of a doorframe. The Earth moved that far in under a minute and erased the coastline that had been there the day before. Since that morning, the Philippine Institute of Volcanology and Seismology has recorded 2,184 aftershocks. 47 of them were above magnitude 4.0, 9 were above magnitude 5.0, and one on day 3 measured 6.1, sending people who had already lost their homes running again into streets still cracked from the first event. The ground has not been still for 4 days. It is not still right now. But here is the detail that tells the real story. The fault that moved on Tuesday morning was not the one the hazard maps were watching. The Philippine fault system, the main strike slip structure running 1,200 kilometers up the spine of the archipelago, is the fault every preparedness model in the country is built around. The rupture that generated the 7.8 did not come from there. It came from the Cotabato-Sindangan fault zone, a secondary structure that the most recent National Seismic Hazard Assessment rated as active but had not placed in the highest priority monitoring tier. The instruments were pointed at the wrong fault. The villages in the rupture zone had been built to standards appropriate for a region adjacent to a major fault, but not directly on top of one. And then the secondary fault moved at a magnitude the regional preparedness framework had not fully modeled for that specific segment. The question sitting inside every seismologist's office in Manila right now is not what happened. The question is what the hazard maps need to say now, and how many other secondary faults across this archipelago of 7,641 islands are rated 1 tier too low. The story does not start 4 days ago. It starts in the geology that built these islands. The Philippine archipelago sits at one of the most tectonically violent intersections on Earth. 3 major tectonic plates converge in this region, and between them have built a landscape of stacked subduction zones, volcanic arcs, and interlocking fault systems denser and more complex than almost anywhere else on the planet. The Philippine sea plate is moving westward at approximately 7 centimeters per year relative to Eurasia. That energy has to go somewhere. It goes into the faults. The Philippine fault itself accommodates a significant portion of that motion in a strike-slip mode, the 2 sides sliding horizontally past each other. But the total plate convergence is too large for any single fault to absorb, so the system distributes the strain across a network of secondary structures, the Cotabato-Sindangan zone among them. Those secondary faults accumulate stress slowly, quietly, for decades or centuries, below the threshold of monitoring attention, and then they release it all at once. Tuesday morning was a release event. The strain built over decades discharged in 47 seconds. The 2,184 aftershocks that followed are the surrounding crust, redistributing the stress, the main rupture transferred to adjacent segments, each adjustment capable of triggering the next. Watch what is moving and what it means for everyone still on the ground. The 2,184 aftershocks are not a diminishing echo of Tuesday's event. They are an active stress redistribution process, and the 6.1 on day 3 is the most important number in that sequence. Not because of what it destroyed, though it did destroy newly erected emergency shelters and 2 evacuation sites, but because of what it indicates about the state of the fault network around the primary rupture zone. Standard Omori Utsu aftershock sequence modeling projects that the decay rate for this sequence is slower than average. The Philippine Institute of Volcanology and Seismology issued a statement on day 2 saying that a magnitude 7.0 or greater aftershock cannot be ruled out for the next 30 days. They did not say it is likely. They said it cannot be ruled out. In hazard communication, that phrase carries specific technical weight. It means the models do not yet have enough data to assign a probability low enough to exclude it. The sequence is still being characterized. The ground is still being read. Here is how the rupture actually works, because the mechanism explains everything downstream. The segment that ruptured broke across approximately 85 kilometers of the Cotabato-Sindangan zone in a strike-slip mechanism with a significant thrust component. Strike-slip means horizontal motion. The thrust component means one side also rode up over the other, which generated the coastal deformation visible in satellite imagery released on day 2, sections of shoreline in 3 municipalities now between 0.6 and 1.1 meters higher than before the earthquake, and sections that have subsided by up to 0.8 meters. The coastline is not where it was. Boat landings that operated on Tuesday morning now sit either above the waterline or below it. The fishermen who survived returned to find their harbors geometrically wrong, water too shallow where it had been deep, too deep where they had always been able to stand. The thrust component also generated a local tsunami. Wave heights between 0.4 and 1.2 meters struck the coastline within 6 minutes of the main shock. 6 minutes is less than the average time it took coastal residents to reach designated assembly points on higher ground. Some of them made it, some of them did not. Scale up. The confirmed death toll stands at 218, with 847 injured and 94 still listed as missing. Those numbers will move. The missing persons figure will move most because 3 of the most severely affected barangays sit in mountain terrain that road crews have not yet reached. The road to Barangay San Roque in Hinatuan has been blocked since Tuesday morning by a debris flow that triggered during the main shock, a secondary effect common in eastern Mindanao's mountainous terrain, where steep hillsides of weathered volcanic rock become unstable under seismic loading and release. Search and rescue teams reached the outer edge of that debris field on day 3. And confirmed it covers approximately 2.3 kilometers of road at depths of between 4 and 7 meters in the worst section. Heavy equipment is on site. The pace of clearing depends on whether the aftershock sequence destabilizes additional material on the slopes above the crews working below. They are clearing a road while standing inside an active aftershock zone on a hillside that has already demonstrated its instability. A regional disaster response coordinator told reporters on day 2 that his teams were making risk calculations that no training manual fully prepares you for. Scale up again, because what happened in Mindanao this week is not isolated inside this single event. The Philippines experiences on average around 20 earthquakes per day, most of them too small to feel. It sits on the Ring of Fire in one of its most densely faulted sections, with more than 300 active or potentially active faults mapped across its territory and a national population of 115 million people. The intersection of those two facts, high fault density, high population density, means that the seismic exposure of the Philippines per capita is among the highest of any country on Earth. The National Building Code was substantially revised following the 1990 Luzon earthquake, which killed more than 1,600 people, and again after the 2013 Bohol earthquake, which killed 222 and collapsed the kind of unreinforced masonry structures that remain common in lower-income municipalities across the archipelago. The 2013 event also prompted a national audit of active faults that led to the current hazard mapping program, the same program that had the Cotabato-Sindangan zone in its second monitoring tier. The audit improved the picture significantly. It did not complete it. Tuesday's rupture has now identified the gap between the improved picture and the complete one, at a cost of 218 confirmed lives and 94 people whose location is still unknown. A structural engineer from the Mindanao State University who reached the affected municipalities within 36 hours of the main shock described what she found in the collapsed buildings in 3 words: no ductile detailing. Ductile detailing is the engineering practice of designing reinforced concrete structures to flex under seismic loading rather than shatter, what allows a building to absorb an earthquake's energy without catastrophic failure, to crack without collapsing, to protect the people inside long enough for them to exit. In a properly detailed frame, the columns yield before they fail. The failure is slow enough to be survivable. In the buildings, she examined across the first 2 municipalities she reached. She found concrete columns that had exploded outward, rebar that had buckled rather than held, beam column connections that had separated at the first large shock. She said she found what she expected to find in buildings constructed before the code revision and in buildings constructed after the revision, in communities where enforcement was limited by the capacity of local building inspection offices. She was not angry when she said it. She was precise. Precision was the only appropriate register for what she was describing. So, what happens next? The aftershock sequence will continue, and the models say it will remain active at levels capable of generating damaging events for weeks. The 94 missing persons in the blocked barangays represent a search and rescue timeline constrained by terrain, equipment access, and the aftershock risk to the teams attempting to reach them. The structural assessment of approximately 4,600 buildings tagged for inspection across the 6 most affected municipalities has processed 1,100 structures in 4 days. The majority have not yet been formally evaluated for reoccupancy. Families are making their own decisions about whether to return to their homes based on visual inspection alone, because the formal inspection queue has not reached them. Some of those decisions will be correct, some will not, and the next significant aftershock will determine which is which. The government has deployed 14,000 food packs, 8,000 shelter kits, and 23 mobile water purification units to the affected area. Distribution is functional in 5 of the 6 municipalities and still disrupted in Hinatuan, where the road to San Roque is still blocked. No one has confirmed what the situation is inside that debris field. No one can yet. No one knows when the aftershock sequence will decay to levels below the damage threshold. The Philippine Institute's operational forecast covers a 30-day window and will be updated as sequence data accumulates, but seismological forecasting at this timescale carries uncertainty, ranges wider than the public communication around them tends to convey. No one knows the final death toll because 94 people are still listed as missing, and the count behind that debris flow is not yet known. No one knows whether the fault segment adjacent to the one that ruptured on Tuesday has had stress transferred to it in amount sufficient to advance it toward its own failure threshold, or how far from that threshold it was before Tuesday morning. The Philippine Institute is running those calculations. The numbers are preliminary. The scientists publishing them are using probability language the way it is supposed to be used, with ranges, confidence intervals, and explicit statements of what the data does not yet allow them to say. The ground in eastern Mindanao moved 1.4 meters on Tuesday morning and has not fully settled since. The fault that moved was not the one on the highest alert. The buildings that collapsed were built the way buildings get built in municipalities where inspection capacity does not match code requirement. The road to 3 unreached barangays is still blocked. The missing persons list has not shortened since day 2. The aftershock on day 3 measured 6.1. The sequence is still being characterized. The hazard maps are already being revised. And somewhere on a hillside above a blocked road in Hinatuan, a search and rescue team is calculating the risk of the next aftershock against the certainty of 94 people who have not been heard from since the ground moved. The toll is not final, the shaking is not finished, and the fault that nobody was watching just became the fault that everybody is watching now. If you want the next one before everyone else, subscribe. That's the only way the algorithm shows it to you first.